Hello Mindsetters, welcome to Learn Extra Live. You grade 11s have been so keen for your show since grade 10, so welcome guys. I'm Katleha and this is Luni. Hi Luni.
Hello.
How are you doing?
I'm good, thank you. How are you
Good,
doing?
good. Luna is the second one of our top 10 guys. So Luni, how does it feel to be here today?
Feels quite awesome. It's a chilled environment. I love everyone here. Everyone's nice and free-spirited.
Awesome,
It's very
that's
nice.
fantastic. So you're happy to be here,
Very
right?
happy.
And you were a Mindsetter once. Tell us about a little bit about yourself, how far you've come, anything.
Well, I matriculated in 2010, so it's been like 3 years now. But it's like, I'm a cool person. I'm very lovable. I'm fun-loving, and I just love life.
Awesome.
Yes.
So that's great. All our Mindsetters love life. So welcome, Luni,
Thank
to our
you very
Mindset family.
much.
She will be chatting to you on the page, guys. So as soon as she steps out, keep chatting to her, ask her questions, anything that you'd like to ask her, because she's here to answer your every question, guys. And also, of course, because we're here, we're on Facebook, www.facebook.com/learnextra, and our Twitter handle is @learnextra, guys. Keep chatting, keep asking questions, and of course we have an awesome new site, guys. By now it's not new because you guys have checked it out already, but in case you haven't, that site is www.learnextra.co.za/live, guys. I'll post everything up on the page so that you can see it. It has notes, it has schedules, it has the actual shows. So make sure that you're on it, guys. Print it or download, whatever you need to do. Stick it up on your walls. Send it to people. Anything that you need to do, guys, make sure. And if you have already joined us on the page, you'll see that we are paying it forward for this month of love, guys. You need to do your random act of kindness and send it to us on our events wall, guys. We're really looking forward to see what you guys have to do out there to give back to others. Basically, it's always nice to give back to others, and we have prizes for that, guys. So if you check over there, and if you may see it, you may not see it, but we have Cheetos, we have these Cheetos are from Simba, guys. I really want to just have one packet of chips there and I'll be so happy. But we also have CDs. We have Donald, we have Kaya, we have Unati. We have all these CDs from Universal. We have our Learn Extra t-shirt from Mindset. We have the lanyard. We have pens. We have our Cheetos notebook. So guys, make sure that you are entering that so that the lucky person will win these awesome, awesome, awesome prizes, guys. Post a clear photo on the page and you stand a chance to win. Join us tomorrow as well, just in case we announce that winner and just in case it's you. Thank you to Macmillan for also sponsoring our show, guys. It's so fantastic that you guys are here to join us, Macmillan. We love you, and of course our Mindsetters all love you. Grade 11s, we are here to do maths, so we need to get right into it with Tamlin. Tamlin, how are you today?
I'm very well. How are you?
Good, thank you. What are we going to be doing?
Today we're carrying on with last week's lesson. We're going to be carrying on with quadratic equations and inequalities. So lots of simultaneous equations and something new that I'm sure you guys have seen in class already called nature of roots.
Awesome. Thank you,
Yes.
Tamlin. Take it away.
All right, welcome guys. And today, as I said, we're carrying on from what we had a look at last week. And today we're going to be having a look at the following. So let's have a quick look at our lesson description. We are going to be having a look at nature of roots. Okay, we'll discuss that in a minute, and we'll get into a lot of detail with that. Simultaneous equations, which remember is essentially solving for two equations where I've got two separate variables. So if you're having to solve an equation where we're looking for the value of an x and a y, or an a and a b, that's when we're looking at simultaneous equations. Quadratic inequalities. Remember, your inequalities is if you don't have an equal sign, but you have a greater than or less than sign. Okay, so we're not looking at one specific answer for x or two specific answers. We're looking at a whole range of answers for x. And hopefully we're going to have enough time to have a look at a nice problem-solving question involving quadratic equations. Okay, so let's not waste any time. Let's start having a look at the key concepts involved in nature of roots. Okay. When we talk about the nature of roots, grade 11s, first of all, what we have to remember is that we are not solving for the roots. We're not actually finding the answers for x. We simply want to know about the answer for x, okay? If we're looking for the nature of the root, we're trying to figure out what type of numbers are we working with. And when we're working with nature of roots, where it comes from is your quadratic equation. If I had x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we all know that that formula solves for x. That's when we're trying to actually find the values for x, okay? But if I just want to know what type of answer we're going to be getting for x, we're actually going to look specifically at what is underneath that square root sign, okay? And we give that a special name. We call that the discriminant, okay? And the discriminant is given or is notated by the symbol of delta. So delta equals b squared minus 4ac. And if we think about this, grade 11s, I'm sure everybody would agree that what's underneath that square root sign there determines the type of number that we get out as an answer for x. If that value underneath our square root sign is positive, the first thing we know is that we are going to get two real answers for x. If that the value underneath your square root sign is a perfect square, not only is it real, but we also know that it's going to be rational because we find that we have a nice perfect square or perfect square root for those values underneath there. If, for instance, we had a 0 underneath the square root sign, now that's quite an interesting one because if it was a 0, whether I added 0 or whether I subtracted 0 in my quadratic equation, I'd land up with the exact same answer for x. So in other words, the roots are equal. All right, so let's have a quick look at this table over here before we get going with an example, and let's just see exactly how we define these nature of roots. Okay. The first one over here says that if our delta is less than 0, so in other words, what is underneath your square root sign is negative. What do we know about the nature of the roots? They are non-real. If delta is equal to 0, as I mentioned earlier, if it's equal to 0, first of all, the roots are real because there's a value there. They're rational because the square root of 0 is actually 0, and that's rational. And they are equal. If I add 0 and if I subtract 0, we get exactly the same two answers for x. Okay. If delta is greater than 0 and it's a perfect square, we can then state that our roots are real. They are rational, but this time they are unequal because whether we add, let's just say the square root of 25 was 5. If I had to add 5 or subtract 5, we are going to get two different answers for x, and hence that we are getting unequal values, unequal roots. All right, and finally, if I have a delta that's greater than 0 but not a perfect square, the roots are still real. They are now irrational because obviously the square root of something that's not a perfect square is going to give us an irrational value. And once again, they're unequal because when we add and subtract the irrational answer, we do get two different answers. Okay. So, grade 11s, what we need to remember before we get stuck into some examples. Nature of roots, we're finding the type of answer that we're getting for the values for x in the quadratic equation. Okay. Right. Typically in nature of roots, there are three ways in which we ask a nature of roots question. Firstly, you could be asked to just determine the nature of the roots, and that's what this first example is doing. So we're here, all we're doing is just call it type 1, if you will, type 1 nature of root question, where what we are doing is determining the nature of the root. I'm just going to say NOR so we can quickly abbreviate that. Okay. All right, so we have been given this equation. They've said calculate delta, which is equal to b squared minus 4ac, and determine the nature of the roots of the equation x squared plus 8x plus 15 is equal to 0. Okay, let's get going. Delta equals b squared minus 4ac. Okay? B, we all know is 8. So we're going to have our 8 squared minus 4. A, which is our invisible 1, multiplied by C, which is our 15. Okay? 8 times 8 is 64. 4 times 15 is 60. And that leaves us with an answer of 4. Okay, so what have we got in terms of delta? First of all, it's positive, so we can say that delta is greater than 0. And what else we can say about 4 is that it is a perfect square. Okay, and because it's a perfect square, when we square root it, we get a rational answer. So to answer the question that they're asking us, therefore, what are the nature of the roots? The roots are real, because it's positive. They are rational, because it's a perfect square. And they are unequal, because if I plus or minus that value of 4, I get 2 different answers for x. Okay, so we've got to remember that that would make it unequal. Okay, so that's type 1 of our nature of root questions. Let's have a look at what type 2 would be. Okay, this time they're asking us to show, or essentially to prove, the nature of a root. Okay, so let's call this type 2. And this is where they're asking us to show, or another word they could use is prove the nature of the roots. Okay, all right, so the nature of roots they're asking us to prove are what? They said show that the roots of the equation 2x squared minus 9x plus 10, which is equal to 0, are real, rational, and unequal. Okay, in order to prove that they're real, rational, and unequal, do we all agree that we are going to have to prove that delta is greater than 0? We have to prove that it's a perfect square, and it's definitely not equal to 0. That would then be proving the 3 conditions that we're looking for over here. Okay, so let's start by working with our delta. So we're going to say b squared minus 4ac, which is equal to my value for b, which is negative 9 squared, minus 4a, which is a 2, multiplied by c, which is a 10. Okay, 9 times 9 is 81, and we are going to land up with 80. So we are getting a value of 1 over there. Okay, so have we landed up with a value for delta that is positive? Yes. Okay, so first things first, delta is greater than 0. The next thing is that our delta is a perfect square, because 1 times 1, or the square root of 1 at least, is 1. And lastly, because our delta is not actually equal to 0, we can therefore say that our roots are unequal. Okay, and so hence what we've managed to do is prove that our roots are positive, they're a perfect square, and they are unequal, so hence they are real, rational, and unequal. Okay, and that is then the second type, so let's have a look at what the third type of nature of root question would involve. We've had a look at determining the nature of roots. We've had a look at proving or showing the nature of roots. So the third type of nature of root question would then be to find the value of a missing variable if they actually give us the nature of the roots. Okay, so let's call this type 3. Okay, and type 3 is to find the value of a variable if the nature of root is actually given to us. Okay, all right, so let's have a look and see what we need to do here. They have said to us to determine the value or the values of p if the equation 2x squared minus 4x plus p is equal to 0, and they're telling us it has real roots. So the first thing we need to ask ourselves is, what do we know about delta if it has real roots? Okay, what we know is that it has to then be greater than 0. That's what we know about it, okay? They haven't specified anything in terms of rational or irrational, or equal or unequal. So I can't make any assumptions about it being a perfect square or about it being equal to 0. But what I can say with certainty is that my delta is greater than 0. It's positive. Okay. So then the next thing we would obviously have to do is work out the value of b squared minus 4ac. And we are going to make that greater than 0. So let's see. I've got negative 4, which is my value for b squared, minus 4a. And my c now is the value of p. Okay. And it's greater than 0. All right, so what we can see we've got over here is an inequality. All right, so we're going to have to solve it as an inequality. So for negative 4 squared is 16. I'm going to get negative 8p, which is greater than 0. If I move over, I'm going to keep my negative 8p on the left. I'm going to move my 16 over. And I hope you're all sitting there thinking, I'm sure everyone's going to remember this. What is our rule when we divide an inequality by a negative? Okay, and the rule is that when we divide an inequality by a negative, my sign must change direction. Okay, we've taken the negative from the left to the right, so hence everything needs to actually turn around. Okay, so therefore our P is going to be equal to, or in this case, sorry, not equal to, less than 2. Okay. So therefore, what are the values for P that would make that quadratic equation real roots? Anything on your number line less than 2 would make it real, okay? And with an inequality, we always typically represent it on a number line. So my values for P would have to be less than 2, okay? So guys, when you're doing your nature of roots, remember your discriminants. Delta equals B squared minus 4AC. And once you've got your discriminant, you need to decide, are they asking me to just determine the nature of roots? Do they want you to actually prove the nature of roots? Or do they want you to find the value of a missing variable if they've actually told you the nature of the roots? Because knowing which path you're taking does influence the way you actually work the question out. So make sure you practice those, guys. And I think we're going to take a short break.
Okay, cool. Thank you, Tamlin. Guys, we're going to take a really quick break. But before that, Looney, you've been on the show now for about 15 minutes, and now you're part of the top 10 presenter search on Learn Extra Live. How does that feel?
It feels great, actually. I actually appreciate everyone who liked my photo and voted for me, because it took like forever to get people to like, but I was like campaigning and all my friends were helping out, so it feels great to be in the top 10.
That's fantastic. Anyone you want to thank specifically or anything you want to say to them?
Just all my friends. Yo, there's a lot of friends that helped me out. If I'd mention all of them,
no, don't. Yeah, no, next thing you're going to lose some friends because of Learn Extra. We don't want that to happen.
But yeah, all my friends, I just want to thank them all for just campaigning for me and helping me get all the likes.
That's fantastic. Thank you, Looney. And Looney will be with you guys on the page, guys. So make sure, grade 11s, you're chatting to her. Ask her anything that you need to ask her, guys. Chat to her about everything and anything because she's here to be with you guys, okay? See you right after this short break. Welcome back, Mindsetters. If you have just joined us, today we are doing grade 11 maths with Tamlin, guys. The page, some people are on the page, those focused mindsetters on the page, but those of you who maybe you forgot that today is maths, because all of you have been like, when is grade 11 maths? I'm so excited for grade 11 maths. So you need to jump on the page and start chatting to us, guys. We are here to answer your every question. So make sure that you are actually, your thinking caps are on, your pens are loaded, and you're writing away and typing away, and anything that you need to do, guys. Remember that you can also learn a lot more by helping other people, guys. So as soon as you see a question on the page and you're like, this is my favorite section and I know everything that's going on, you can give it a bash and try answer it, guys, because it really does help you as well in trying to remember all those rules and all those questions and anything that you need to know. Isn't that right, Tamlin?
Absolutely. And in fact, the one thing that we're about to go on to now is something called simultaneous equations. Okay. And if you're going to pay attention, now's the time to do it, because simultaneous equations is one of those sections that manages to creep its way into many, many other sections.
I remember that section.
Absolutely. So now's your time to be listening, okay? All right, grade 11. So let's go back quickly to our key concepts over here. We've had a look at nature of roots, now we're having a look at simultaneous equations. As I briefly mentioned at the beginning of the show, a simultaneous equation is necessary when you've got two equations with two variables that you need to solve for. Okay, so if you've got an x and a y, or as I mentioned earlier, an a and a b, or a p and a q, it doesn't always have to be x and y. But if there's two different variables and you need to find the value of each, your simultaneous equations is how you're going to go about doing it. Okay. All right, so let's have a look first of all at an example over here. When we talk about simultaneous equations, all right, if we were to actually, there's more than one way to solve it. And if we were to think about it in a graphical way, all right, in terms of a graph, simultaneous equations in terms of graphs represents where your two graphs intersect each other, okay? So for example, if I had a parabola and I had a straight line graph, and I needed to work out where those two graphs intersect each other, that would be a case of solving a simultaneous equation. Okay, so therefore, we can solve simultaneous equations in a graphical way, or we can solve them in an algebraic way where we actually do the calculations. So we're going to show you both, all right? So let's have a look at this example over here, and let's see how we can look at it in terms of solving it using graphs. Okay, they've told us over here to draw the graphs of y equals negative x squared plus 9, which, because it's an x squared, we all know by now is a parabola, and y equals 2x minus 1, which we all know by now is a straight line graph. And they've asked us to draw it on the same set of axes, and from your graphs determine the points where the two graphs intersect each other. Okay. Right, let's see. If I've got y equals negative x squared plus 9, let's do a little bit of grade 10 revision for a second here. Remember your parabola. If you have got 9 in this term over here, remember that that represents your y-intercept, which in a case like this is always also going to be your turning point, okay? So let's put our 9 over there on the y-axis. And to work out the two x-intercepts, we're going to let y equal 0. So I'm going to say negative x squared plus 9. I'm going to get rid of the negative, which makes it positive x squared minus 9. And I'm going to factorize. So we get x minus 3, x plus 3. And that gives me two x-intercepts, one being positive 3 and the other being negative 3. So on my graph, I'm going to put a positive 3 and I'm going to put a negative 3. Okay. All right, just so we don't run into space problems, I am just going to take that away so that we don't get ourselves confused. Okay, so the parabola, because it's a negative x squared, that negative over there is telling us that our shape of our parabola is going to be a negative frowning parabola. Okay. So we've got a y-intercept passing through 9, it's got an x-intercept through negative 3, and it's got an x-intercept through positive 3. And there's our parabola, more or less. Okay, it's not exact measurements at this point. And if you ask to do it, obviously, the more accurate your measurements, the more accurate your answer is going to be. The straight line graph of y is equal to 2x minus 1. Okay, so that's going to have a y-intercept of negative 1. And a gradient of 2. So I'm just going to plot my gradient as a 2 over a 1. So therefore, my straight line is going to pass through there and down through there and all the way down. Okay. So I'm going to have to actually increase the length of my parabola and my straight line, and to make sure I get 2 points of intersection. The first being over here and the second being over there. Should we change the color? So there's my 2 points of intersection. Okay, so reading it off the graph would then be a case of saying, okay, well, looking on the x-axis and looking on the y-axis, where do the graphs cross each other? So let's have a look here. If I take my line directly down from my point of intersection down to my x-axis and directly across to my y-axis, and if I do the same over here, I'm going to take it directly up to my x-axis and directly across to my y-axis, we're more or less going to be seeing that, okay, I can't tell exactly because I can see it doesn't fall on an exact number, but I can see more or less that the x coordinates over here are going to be somewhere around, I'm going to assume 2.5, 2.6 it looks like. And this over here, okay, we're going to have to take a guess, guys. We're going to have to prove it later, but it looks more or less plus minus 3. Okay, these are estimations at the moment. And down below here, okay, well, if that's negative 3, it looks something like negative 4, but we'll have to prove it in a minute. And down below here, yeah, it also looks quite low, so let's take a guess and say negative 9. So as you can see, the graph is not 100% accurate. It gives us an idea, but we're probably going to have to rely on algebra to actually prove it exactly. Okay, so now that we know what we're looking for, let's use algebra and let's actually prove it, and let's see how close our estimations actually are to the exact answers. To prove them simultaneously, we're going to take both equations. I'm going to take my y equals negative x squared plus 9, and I'm going to take my y equals 2x minus 1. I'm going to call that equation 1, and I'm going to call that equation 2. Now, this requires very little manipulating because on my left-hand side, my first equation is equal to just y. And on the second equation, the left-hand side, is also equal to y. So in each equation, if they're both equal to y on the left-hand side, what's on the right-hand side would then also have to equate to each other, all right? So basically what we're doing is we're essentially going to substitute the value of y from equation 1 into the value of y in equation 2, which means I'm going to have negative x squared plus 9 is equal to 2x minus 1. Okay, and can you see what we've done is we've actually managed to get rid of the y, and now what we're doing is solving for the x, okay, which helps. So now we've gotten rid of one of the variables. So let's solve for x here. We've got x squared, negative x squared. I'm going to bring my 2 over, which is going to be negative. And I've got 9, and if our 1 jumps over or comes to the other side, it becomes 10, and it's equal to 0. Okay, I'm going to divide through by a negative, which has the result of changing our sign. So I've got 2x minus 10 equals 0. And now what we would want to obviously try and do is factorize it. But if we look, we can see that it's not going to factorize. Factors of 10, 5, and 2, unfortunately, it's not going to get us to 2 in the middle there. So what do we have to rely on? I'm sure you remember from last week, if the trinomial doesn't factorize, use your quadratic formula. Okay, right, so quadratic formula, which is negative b. Now the b, guys, we know is the one in front of your x, so it's your 2, plus or minus the square root of b squared minus 4ac, which is negative 10, and it is all over 2a. Okay, while we're at this, I actually wanted to point out quite a nice little website for you guys to have a look at. Okay, if you've got some time and you're trying to solve these quadratic equations and you just need to check if your answers are correct, you guys can go and have a look at this website over here, if we can get to it. If we can't, you guys can write it down and have a look at it at home. Basically, it's really cool. It's a quadratic functions calculator. Okay, so it actually solves the quadratic equation for you. So I'm sure Kat's going to put that on the website.
I sure am.
And go and have a look at it. It's actually it's quite nice, and just to help you, give you a little bit of backup when you're solving quadratic equations and you just want to check your answer. Okay, so www.math.com. and then /students/calculators/source, and then finally /quadratic.htm. Okay, quite a mouthful of a website, but go and have a look at it. It's really useful. Okay, all right. But what I'm going to do very quickly is I'm also going to use the calculator. All right, so let's just put it into, let's use our calculator quickly to type in everything over here. So let's have a look. I've got negative 2. Let's start with our plus, the square root of 2 squared minus 4a, which is a 1, and b, which is a negative 10, and it is all over 2 times 1, which is 2. Okay, so we're getting a 2.316. So let's round it off to 1 decimal place, a 2.3. So my first answer for x is equal to 2.3. And let's just go back to our calculator for a second. Let's just replay our values, and all I'm going to do is replace the plus with a minus. Okay, and we get the other version, which is negative 4.3. Okay, so x equals negative 4.3. 4.3. Let's have a look and see how close we were to our previous answer. We said 2.6 over there, and we've landed up with 2.3. So we actually weren't too far off. We were pretty close. And the other value, we said negative 4. That was our estimation. The actual value was negative 4.3. So we can see the graphical method wasn't far off, but it wasn't 100% as exact as working it out algebraically. Okay. Right, so now that you've got the values for x, remember you do still need to work out the values for y. And this is the easy part, because all you have to do is take each value for x and sub it back into either equation 1 or equation 2. And let's be honest, we want to try and find the simplest way to an answer, so choose the simpler equation. Okay, I think we all agree the straight line graph was the simpler one, and that was the 2x minus 1 equation. So what we're going to do is we're going to substitute the first value for x, which was 2.3, and we'll work out our answer. Let's just move our calculator over. Okay, clear it. So we're going to say 2 multiplied by 2.3 minus 1, and that value was 3.6. Okay. So my y value is 3.6. So let's actually write that coordinate. So the x coordinate was 2.3 and the y was 3.6. And over here I've got y equals 2 multiplied by negative 4.3 minus 1. Okay, so let's move it to this side. Let's clear that over here. So we're going to say 2 multiplied by negative 4.3 minus 1 equals, and negative 9.6. Negative 9.6. Okay, so the coordinates of that point of intersection was negative 4.3 and negative 9.6. Let's go back and see where we're close. We had a 3 over here as my y-intercept, and we worked out that the 3.6 was the answer that we actually had in actual terms. And over here we had an estimated value of 9, and we got a negative of 9 at least, and we got an actual value of negative 9.6. So we can see once again we were pretty close. We weren't 100% exact on the graph, but that's why we need the substitute. That's why we need to solve a simultaneous equation by the substitution. Okay, so let's have another look at another simultaneous equation. It's such an important concept for you guys to know, and that's why it's really important that you understand it. Okay, once again, I've got two equations. I've got an x minus a 2y, which is equal to 0, and I've got an x squared minus a 2xy plus y squared, which is equal to 1. Okay. When you're working with a simultaneous equation, you're typically going to have one equation slightly simpler than the other, all right? So what I need you to do is look at the simpler equation, and then within that simpler equation, I want you to identify either the x or the y, or whichever the two variables are, the simpler one to get on its own, okay? So looking at it, I can see that I've got an x and a minus 2y. Now, I'm sure you guys agree it's going to be much easier to get x completely on its own. So therefore, what I'm going to do is I'm going to move 2y over my equal sign, in which case it will become positive 2y, and I've got plus 1. And we're going to label that equation 1. My other equation, the x squared minus 2xy plus y squared, which is equal to 1, we're going to label that equation 2. And once again, what we're going to do is we're going to substitute the x from equation 1 into the x's in equation 2, all right? So where I had an x over there and where I've got an x over there, we're going to substitute them with the value for x that we found in equation 1. So what we've got is, instead of x, okay, let's use our green to substitute. Instead of x, we have got 2y plus 1, which is being squared, minus 2. Instead of x, remember x is going to be 2y plus 1, and multiplied by another y plus y squared equals 1. Okay, so I hope you guys can very clearly see what I've done over there. I've just replaced every value for x with now this new value of 2y plus 1. Now it's a case of careful working out. Okay, now you've really got to just stay focused and don't make any silly mistakes. If we FOIL this out, we are going to land up with 4y squared plus 4y plus 1. Just be aware that this y and that 2 are both being multiplied to the bracket, so it's probably better to take the y away from the back of the bracket and just join it with your 2, just so it's clearer as to what's going into your bracket. So therefore, when we distribute, we're going to land up with negative 4y squared and negative 2y, okay? And then I've got a plus y squared, which is equal to 1. Okay, so now we just have to tidy up. So I've got a 4y squared minus a 4y squared, which will actually cancel each other out. And what are we left with? I've got a y squared, which is on its own now. I've got a 4y minus a 2y, which is going to leave us with just 2y. And I've got a 1 on the left-hand side, a 1 on the right-hand side. So when the 1 jumps over, it becomes -1 and it cancels out. So therefore, that's what we're left with. Okay. So now it looks a lot simpler. We're going to factorize it by taking out a highest common factor. So we're going to have our y plus 2, which is equal to 0, giving me 2 answers for y. I've got a 0, or I have got a -2. And finally, what do we have to do to find our x? We take our 2 answers for y, and we substitute them back into either equation 1 or equation 2 to get the values for x. You guys give that a try while we take a short break. And when we come back, I think we'll give you the answers.
Awesome, guys. So get those X's while we are on a break. Remember, guys, focus is really key. So focus during this break. Do not move off your seats, and we will be right back. I'm so glad you guys are back, because this is one of those shows that cannot be missed, guys. We can't stress how important this section is, and once you have it in the bag, guys, you can do anything that you want to do. Before the break, I was thinking, wow, talking about X's, it is Valentine's Day month, or Valentine's month, let's just say, on the 14th of February. So this month, we are doing random acts of kindness, guys. Please, whatever you do something random, but something extremely kind, and ask someone to take a picture of it, put it on the page, on our events wall, of course, and we will be picking a lucky winner to win such an awesome hamper, guys. This hamper, I'm looking at it now, and I'm just like, I just want to eat it. It's a Cheetos hamper. Thank you to Simba for all these amazing chips that you gave us, and thank you to Universal as well for giving us those 5 CDs, guys, and also that Mindset Learn Extra t-shirt that you guys have been dying for. Now you have a chance to win it, and also some lanyards and some pens and some notepads. Guys, come on, guys, post those things on the page. I know that you guys already do random acts of kindness. Now, you guys just have to take a photo of it and send it to us, and we will be picking a lucky winner. So make sure that you join us the whole week, as a matter of fact, just to show that you actually really want to win, and just so that you can listen out for your name in case you do win. Over to you, Tamlin.
Okay, right. I hope you guys have solved for those 2 values for x. And if we did it correctly, the first we would land up with x is equal to 1. And x is equal to -3. So therefore, just remember to conceptualize it as a graph. If I were to draw the picture where these 2 functions actually intersected each other, so where they crossed each other, it would be at the point of +1 and 0, -3 and -2. So that again would represent the points of intersection. Okay. Go practice your simultaneous equations. They're not difficult, but they do need a little bit of working on and just a bit of calculation. So watch out for silly errors that can creep into those. The next thing we need to have a look at is your quadratic inequalities. Okay, I'm quite sure at school you guys are busy with these at the moment, and we just need to be aware of how we go about solving them. Okay. What we need to be very clear on is that a quadratic inequality does have a special method involved. So it's not quite as simple as just solving it as if we would solve a quadratic equation. There's a bit else involved over here. All right, so let's have a quick look over here and just see. What I'm going to do very quickly is I'm going to actually show you 2 different ways in which to go about solving it, just so that if you've seen it in school, one way or the other, you know that it's correct either way. Okay. The first method is going to go like this. I'm going to bring my x squared and I'm going to bring my -16 over the less than sign. So we've got x squared minus 16 is less than 0. And this is a typical start to a quadratic equation. Hey, we would bring everything to the left-hand side and we would make the right-hand side equal to 0. All right? So now let's have a look. If I factorize the left-hand side, I'm going to land up with x minus 4 and x plus 4. And this, grade 11s, is where you now need to please be careful, okay? Once you have factorized them, we now have to go and find what we're going to call our critical values. Critical values do come straight from the 2 brackets where we solve for x, okay? But those are not the answers that we're just stating. That's not just what we land up as our answer. So our first critical value is going to be 4. And the second critical value is going to be -4. Now those are what we are going to plot on our number line. So on our number line, we would obviously have -4 first, and we would have +4 second. Okay, now we're going to look at this in terms of a graphical way, in terms of looking at it as a parabola. If I had x squared minus 16, I know that the way it would look in a graph is it would be a positive smiling parabola. And what I've essentially done is I've worked out that it would have x-intercepts at -4 and +4. So let's draw this parabola and let's see what it would look like. Okay, so let's take it and let's draw our parabola through the x-intercepts of -4 and +4, and it's smiling. And what we are interested in is, where is it less than 0? Well, it's less than 0 everything between negative and +4. So therefore, what is the solution to my inequality? My values for x are going to be everything between. Now I'm going to use a round bracket, and why? Because this is not included. It's going to be everything from negative to +4, and once again it's a round bracket indicating that it's not included. Okay, and so that's your answer. Everything from negative to +4 would satisfy that inequality. Okay, looking at it another way that you may have seen it in class, you start off exactly the same way. We bring our 16 over and it's less than 0, and we factorize. Okay, so we get our -4 and we get our +4, and once again we get our critical values, which again is 4 and -4, which we plot on the number line. So far the two methods look exactly the same. This is where they differ slightly. What we now do is we put -4 and +4 on our number line, and we're going to actually create columns underneath each of those numbers over there. All right? And we take the two brackets that made up those critical values, which was x minus 4, which I'm going to write over here, x minus 4, and x plus 4. And this is what we do. We choose a number on our number line less than -4. All right, let's take -5 as an easy example. If I were to substitute -5 into my value for x, I would have -5 minus 4, which essentially gives us an answer that is negative. And that's what I'm interested in. If I took that -5 and I substituted it into this x, I would get -5 plus 4, which is -1. And again, all I'm interested in is that it's negative. Okay? Now let's take something on our number line between negative and +4, and I think the obvious choice here would probably be 0. So let's substitute 0 into this x over here, which means I would have 0 minus 4, which is negative, and 0 plus 4, which is now positive. And greater than 4, let's take 5 as an option, so therefore 5 minus 4 is now positive, and 5 plus 4 is positive. Okay, and what we do is we actually now find the product of those signs. So let's just draw that nice and neatly. So we say negative times a negative is a positive, negative times positive is negative, and positive. And remember again, we were looking for where it is less than 0, so we're looking for where it's negative, and it's negative from there to there. That's the negative portion of the graph, which means it's from negative to +4. And what we would do on our number line is we'd indicate it with 2 open dots and a line between those 2 dots. And we would say x is an element of negative to +4. Okay, so between those two methods, I hope that makes sense to you guys as to how you've actually done that in class, how you solve quadratic inequalities. But let's have a look at one that's maybe just a little bit more interesting. Let's say I've got this. I've got 2x squared minus 7x plus 3, and this time it's greater than or equal to 0. Okay, so let's just get rid of that. I need to now solve this quadratic inequality. Okay, first things first. As it stands at the moment, everything is already on the left-hand side. My right-hand side is already equal to 0. So if that's done, we don't have to worry about that. So remember, the next step is we had to factorize our left-hand side. So let's factorize it. And we're going to land up with a 2x and an x. We're looking for 7. So therefore, we're going to have a 3 and a 1, where I get -6 and -1, which would get me my -7. Okay, remember from here, we need your critical values. And my critical values are, in this case, positive 1/2 and 3. And I'm going to plot those on our number line. Okay, first things first, it would be a half, and 3. Okay, I'm going to use my parabola method just because it's that much quicker. If it was if this was a parabola, if I were to draw it, it would be a smiling parabola through the points of a half and 3. And what I'm interested in this time is where they are greater than or equal to 0. So it's greater than or equal to 0, everything from negative infinity up to and including a half. And then from everything from and including 3 off to positive infinity. Okay, those are the positive portions of our graph. So therefore, what are my values for x? It's everything from, round bracket, from negative infinity to a half. And this time I'm going to make it a square bracket because we're wanting to indicate that it is included. And then we do our union sign. We show that there's a gap between the two of them. And then I say from 3 to positive infinity. Please watch out, grade 11s, when you're writing your interval notation, that it always gets written from smallest to biggest. So what do I mean? Please don't invert those and write that as a half to negative infinity. If we think about that, that doesn't make sense. It must be written from lowest to smallest to biggest. Okay. All right, guys, so that is how we're solving our quadratic inequalities. And again, this also tends to creep into other sections as well. So you can't just put it in a box and isolate it into this quadratic section. You need to remember it so that later on, if it creeps up again, that you do actually remember to apply this method. Okay. Okie dokes. I'm going to start talking you through this example over here. We're definitely not going to have enough time to finish it off, but what we can do is post it on the website just as an answer. But I'll start you off and let's have a look over here. One of everyone's favorite questions is the number, the problem-solving question. I'm sure you remember those. Hey, Kat, everyone loves those.
I know. Reading that thing brings back like awkward memories.
Yeah, the problem-solving. But you know what? It's actually not that bad. So let's have a look over here and see. They've told us that a pilot flies a small plane 420 kilometers from Joburg to Nelspruit. On the return journey with an additional load and a headwind, his speed is 90 kilometers per hour slower and the trip takes him 30 minutes longer. So what we're having to calculate is the speed for each journey and determine to the whole number. Okay. What you want to do, guys, is set yourself up a table. Typically, these questions over here work nicely with a table. And I'm going to divide it into 3 columns and 2 rows. Okay. And I'm going to label this one to Nelspruit, and this one's going to be from Nelspruit. Now, this is going to be classed as a speed or distance, speed, and time question, where we're dealing with the ratio of speed, distance, and time. Okay. All right. The distance of our journey, it doesn't matter how fast or how slow he was traveling. If the distance from Joburg to Nelspruit is 420 kilometers, there or back, it's not going to change. So the distance of both of my trips to and from is 420 kilometers, okay? Do we know how fast he traveled to Nelspruit? Well, no, we don't. But what we do know is that when he traveled back, he was 90 kilometers per hour slower. So let's do this. Let's call his speed to Nelspruit x kilometers per hour. And his speed back from Nelspruit would then be x minus 90 kilometers per hour. Okay. And his time, well, this is now the question mark. This is now a big blank. All I know is that the difference between the to and the from trip is a difference of 30 minutes. But how long did it take to get there and how long did it take to get back? We don't know, all right? But what should look familiar to you guys is our distance, speed, and time triangle. Okay, the way your triangle works is that to calculate your time, you look at your distance over your speed. So if I do that, if I take my distance, which was 420, I'm going to divide it by the speed of x. And in the second, in the way home, the distance of 420 was divided by x minus 90. Okay, so those two equations represent the time of your trip. So this is what we have to do. The longer trip was obviously the one he was traveling slower on, all right? So the longer trip was the second one, the 420 over x minus 90. And I'm going to subtract the faster time, which is 420 over x. And what they told me in the original question is that the difference between the times was 30 minutes. Now remember, we're talking about kilometers per hour. So we need to represent it in terms of hours. 30 minutes is half an hour. All right. From there, that is just a normal quadratic equation to solve. Okay, so you're now going to actually find an LCD, solve for x, and you'll be able to work out how fast he traveled on his way to Nelspruit and how fast he traveled on the way back. Okay, again, don't be scared of those problem-solving questions. Once you do enough of them, you start to see a bit of a trend and a common thread throwing through them. So just go and practice them. And I think that's it that we can fit in today.
Time always goes super fast on the show. I don't understand why. I know that you guys also wish that we had an extra hour, but unfortunately, we do not, guys. Thank you so much for joining us today. You guys have been absolutely amazing. Keep learning more and learning extra, guys. This is actually going to be such an awesome maths year, so keep joining us every Monday, same time, same place. Bye, guys.